In this video, we're going to talk about properties of the dot product. So I've listed the beginnings of a few properties here. The first property is that A dotted with B is the same thing as B dotted with A. So in other words, the order in which you dot two vectors does not matter. Or the technical way to say this is that the dot product is commutative. So property 2 says that if you have A dotted with B plus C, where everything here is a vector, the A distributes, and you get A dotted with B plus A dotted with C. Property 3 involves having a constant, some number, k, being multiplied by one of the vectors in this dot product. And when you have that, you can pull the k all the way in front and have k times A dotted with B. And the same thing is true if the k was multiplying the second vector, if it was multiplying the b. So all three of these are equal, where k in this property is a scalar. It's just some number. It's not a vector. So the fourth property is that when you dot a vector with itself, this is actually equal to the length of a vector squared. So make sure you see why. Think about a vector being written in terms of its components. Let's just say A1, A2, and A3. And if you take this vector dot itself, you would get A1 squared plus A2 squared plus A3 squared. But that's just the length of A squared. Okay, so that's where that comes from. But when we take the length of a vector and we square that, that's definitely going to be non-negative. It's definitely going to be greater than or equal to 0. And moreover, the only way for A dot A to be equal to 0 is if and only if and only if, we would need the length of A squared to be 0. So that means the length of A has to be 0. And the only way for the length of a vector to be 0 is if the vector is the 0 vector, if all of its components are just 0. So symbolically, we express the phrase if and only if as a double-sided arrow like this. So in the next video, we are going to define, oh, whoops, sorry, I got carried away there. There's one more thing I wanted to write down, which is when we take the length of a scalar multiplying a vector, so k times A, that equals, I'm able to pull the k in front of this length, but when I do that, I have to put an absolute value around it, because if k was negative, the length of a vector better not be negative, so I need to put an absolute value around it, and I'll get k times the length of that vector A that's left over. Okay, so that is actually the last thing I wanted to talk about in this video. In the next video, we will introduce what's called a projection of a vector onto another vector.